I would like to recall my days earlier where I used to cycle from home to the college and back with a comfortable ride all the time. And the same thing is not possible today, as we know that cycling in Bangalore kind of a city is not so easy today. So if we have to ease out the living conditions in urban areas, what can be done and how space can help you out? That's the main topic which I will be discussing with you. As we know that space is now with plenty of satellites, and these satellites do provide excellent data that allows you to understand the ground much better, be it urban, be it rural, be it forest, agriculture, any area. It is pretty easy for us to look into and then start analyzing and understanding. So the focus here will be to see how the satellite data can be used for making things better, particularly for a city like Bangalore. This is a typical example of how Bangalore would look like at a sub-centimeter resolution, where we can look at various areas, like it could be infrastructure development, it could be urban planning, it could be water body related activities, it could be drainage density, it could be various other activities that happen in an urban area, how that can be beautifully seen from space and how you can manage them better so that you can have better living on the urban areas. In fact, the beauty of urban growth manipulations that happens on a year-to-year basis can be beautifully monitored from space. We have a Bowen geoportal from ISRO which provides more than 200 cities database, which provides excellent information about how the cities are changing over a period of time. For example, if you look at 1990s data and 2020 data, you will be able to see the dramatic changes that is taking place from one area to the other area. In fact, you can pick and choose a city and you can literally start looking at what's really happening to that particular city. I have two examples here, but on an interactive mode, a particular portal can give you much more information about what's really happening to the cities. I'm trying to show you Mumbai as well as Chandigarh. Of course, Chandigarh is one of the well-planned cities, but Mumbai is going quite rapidly in all directions, and you can see in which direction is this particular city growing. Now that we are looking at multiple cities, how they are growing, and it is also necessary for us to see in what direction can we plan and take so that the living in the urban areas will be much better. So towards that, we will try to take a look at Bangalore, for example. This is an image of Bangalore, what you see in front of you, but I am trying to take you back 50 years. This is a 1973 image, what I am showing you, where the urbanization is in the center, a dense urbanization. You do see a metropolitan boundary, where the boundary is the area for which the whole planning is done. And you can see the drainage density in the black, and the drainage lines can be seen so beautifully. And you do see plenty of greenery all around Bangalore. In fact, we used to call this Bangalore as Garden City those days. But today possibly we don't call that. Why? I'm going to show you the reasons for it. If you move to 1976, the image slightly changes, but not much, because 3 years from 73. But I keep changing from year to year. You can slowly watch the kind of urbanization, the blue color in the center, the way it is growing, and various other features what you see is diminishing one by one. For example, water gets reduced or water gets choked. The drainage areas where the water is supposed to naturally flow starts slowly choking off, and urbanization starts engulfing them step by step. So you can see those blue patches in the center slightly growing every year. For example, we are moving into 1999. So you slowly go towards 2000. For example, 2000 image shows a much bigger blue coming up in the center, but still we have not reached the metropolitan boundary. But when you start seeing a 2010 image and 2015 image, you start seeing a dramatic change that is taking place for urbanization. So we started off from 1973, and these are multispectral satellite images, what I am showing you, where visible spectrum and infrared spectrum data is used and color composites are used for analytics. So when you look at close to 2020, an image of this kind comes up. This is a typical example of how the urban growth or the urban sprawl can be beautifully seen from the space data. This is a typical example of how historical data can be analyzed, and this historical data can be taken through AI-based techniques to see the learning that comes up. That means what good things did you do, what really bad things we did, or wrong plannings we did, so that it is possible for us to correct ourselves so that the future planning can be rectified. In fact, this is the image we are living in today. This is the 2024 data just taken a couple of days back, which shows you the Bangalore has literally grown out of metropolitan boundary, which was set up much earlier, and we are actually growing in all directions. So everybody will be interested in understanding where are we heading. So a typical example of how you can move off from a serene climatic conditions of 1973 and you start growing from 1973 downwards to 2024, wherein about 50 years, in fact I've taken you through a time travel of about 50 years, wherein in 50 years things have changed so dramatically. In fact, the impact of such a growth is directly hitting everybody on the ground today. For example, you could have plenty of urban floods. Every day there is a problem of traffic. So the living conditions as compared to what it used to be and what it is today is completely changed. So are there solutions to these? We will start looking at that. But before that, I thought I'll just draw your attention to what was the kind of population we were looking at 1973. In 1973, the population was something like 1.8 million. Today, we are talking about more than 15 million. So we have grown more than 13 times or 12 to 13 times in population. Now add to this the kind of infrastructure growth that has taken place, because you have gone 14 or almost 14 times of what it was, and you have added infrastructure, you have added a huge amount of four-wheelers, eight-wheelers, two-wheelers, three-wheelers. Don't know how many of those vehicles have come onto the roads. So if you add them all, you will literally get an idea from 73 to 2024, the kind of changes that has taken place is clearly shown. Of course, the analytics also shows you the equation of the changes that has taken place. That means at what cost did the urbanization take place? We have lost a lot of agricultural area. We have lost a lot of tree-clad areas. We have also lost quite a few water bodies. And there are plenty of stone quarries that is coming up, which is helping in construction of newer and newer houses or newer and newer infrastructure. So the equation is very clear. We have lost almost about 600 square kilometers of area for the built up. At the same time, we have lost about 600 square kilometers of vegetation. So it's almost like you lose vegetation, you get the concrete jungle, and the growth, as you see in this particular slide, very clearly shows the last 10-15 years, the growth rate has been something like 245%. It's pretty significant. That's why Bangalore is possibly one of the fastest growing cities in the Asia or in the world itself. Now, when we see such an image, it is pretty chaotic, but we would like to know what is the direction in which we are really growing. So on the northeastern side, there is a dramatic change that is taking place because of the presence of the new international airport. We also see a dramatic change that is taking place towards the north, the southwest area, southeast area, where there is Hosur and other areas. So there is a lot of industrial areas that is coming up there also. On all directions, every patch of Bangalore you see all around the surroundings, the expansion of Bangalore is going pretty significant, and a lot of stone quarries are happening in a monolithic rock area where we are supposed to protect such areas. Even such kind of things we are able to see. So if we look at today's satellite data, the visual indication very clearly shows that we are going towards pretty bad times in the future unless we get into proper planning. So the planning can be what? We should be looking at technology. Space is one technology which we can integrate with possibly IoTs, with drones and various other sensor techniques, which helps us in getting us near real-time information about various parameters in the urban areas. So we are looking at terrain itself. For example, this is a stereo imaging from space, the Cartosat-1 series of satellite, which has provided fantastic data that helps us in understanding the terrain. Because any development you do, unless the terrain is understood properly, there's no point in doing it. I'll show you typical examples of how bad we can go if we don't understand the terrain. This is a typical example, what you see in the slide, showing you the terrain of Bangalore. It's a beautiful terrain of Bangalore, which possibly should never flood any time, because the highest point is almost toward the center of Bangalore, and the water drains on either side of Bangalore, and any amount of rainfall should drain out the water. But sadly, last 2-3 years, we are seeing urban floods predominantly. This is purely due to choking off those drainages what we see. So it's possible for you to get the contour data, and on the contour data, it is also possible for you to bring in the drainage density. So this drainage density very clearly tells you how the water is supposed to be managed. As you see in this particular slide, the terrain, and on the top of it, the gradient data, and the gradient data shows you how the water is supposed to flow. And if you are able to manage that water flow, it is possible for you to easily understand how to manage them. So here is a 1970 data from where it is possible for me to extract the drainage layers. For example, all the drainage layers gets extracted from that, as you see here in this particular slide. And from this, it is possible for you to take those drainages, extract those drainages, take the recent satellite data like 2024 data which I was telling you, and you can bring back those drainages on the top. You will be easily able to find out the choked drainages, where they are, and where the choking is taking place, where the flood is taking place because of that, and it is possible for us to address them straight away. So that's the advantage of using the old data, extracting information, bringing it onto the new data sets, and using that for correcting the ground realities. One typical example I would like to show near Belandur tank, which is in the news all the time. So here what is happening is the flooding is not so prominent unless it rains very heavily in this area. But what we see here is a typical example of how it was in 70s. This is an old Corona image which is available from US, because these are old flight images, and you are able to very clearly see the floodplain where the water used to flow very beautifully. But over a period of time, what has happened is the urbanization has completely changed this whole place. In the sense, the entire drainage, the floodplain has been covered with settlements. So you see the old image and the new image, you can see the changes that has taken place, which is choking completely. That means the flowing water has literally been blocked. And this blocking has created a lot of problem as far as water flow is concerned. So the natural water flow is blocked, and when the natural water flow gets blocked, you get into the problem of floods. In fact, 2022, October, we had very severe floods in the northeastern part of Bangalore because of very heavy rains. It was the same reason where we are talking about very heavy amount of choking that took place in Bangalore. Again, just recently, 2024, just last month, we had floods again north of Bangalore, addressed very heavy problems of rains, and the choking took place. Both these occasions, the problem, what has been analyzed from space data, very clearly shows that we have choked the drainage. The amount of water came in was much more than what the drainage could have handled, because it is already choked. So this information is being utilized in such a way that we can come out with newer ways of addressing the floods. For example, in 3 phases, the whole problem can be solved. The 3 phases are very clearly shown. The first phase is with respect to the northeastern range, where we can de-choke the drainages. We can see to that the water flows very smooth. And on the other side, the western portion, where the Kaveri water, the drain that goes to Kaveri water again can be de-choked. And further up towards the Hoskote on the northern part, the third phase can also address these de-choking. So under these 3 phases, it is possible for one to change the whole thing. Of course, the other part is you can use the 3D OpenStreetMaps to address the traffic snarls what we see every day, and it is possible for us to understand real-time situation where we can address the problem related to the traffic. This can be easily understood. That is also a flow. Traffic is also a flow, water is also a flow. These two flow programs, if we can solve it, Bangalore would be much better for living. This is an example of 3D city modeling where it is possible for you to use the three-dimensional images from space, and we can do photogrammetric techniques for evolving images. These images will help you in understanding or creating a 3D GIS. 3D GIS can be used for real-time problems, especially by bringing in a lot of interesting sensors which tells you about the dynamics of Bangalore, and this can be controlled in the real time. This helps you in a very big way. For example, you can create a 3D city model that helps you to understand the conditions on the ground through images that can be taken into a virtual reality kind of an application. So virtual reality and augmented reality is yet another technology that can be brought in to help out in understanding the problems of the humans on the ground. And there is something called as digital twin, which we are trying to attempt. This is one example of digital twin where we are able to see the Vidhan Soda as well as the High Court area. Just as an example, I'm trying to show you. But basically what we are trying to address from the 3D city models is that we would like to see whether we can create a digital twin onto a computer, solve the problem on the system, and once you are able to solve the problem on the system, you take the whole problem solution onto the ground and you can start solving them. So two important problems can be addressed. One is straight away the water related issue, and the other one is with respect to traffic. And of course, there are many other issues in the urban which can also be addressed once you are able to create a simple technique of digital twin. That's what we are talking about today from space. So space tech provides the right options for urban management. The only way forward for sustainable cities in the future is to use the technology, and use the technology in such a way that you integrate space and the ground and in between drone also, so that you are able to integrate the right kind of technologies for real-time solutions to people's problems. Thank you very much.